So organic compounds are like
I'm just recording the session today.
ethanol,
Okay.
um, ethanol, water.
You are
Is it
saying
like
water is
the
an
ones we can
organ.
find, like the natural ones?
No, that was the answer what you said last class. We wrote a definition for organic compounds. Compounds can be two types, organic and inorganic. Water is not an organic compound. It's not about natural stuff. Water is H2O. It's not an organic compound. Yes, dear. Organic compounds, take out your note. See if you have it.
Yeah.
Okay, what are hydrocarbons?
The compounds that have only hydrogen and carbon.
Yes, compounds which have only hydrogen and carbon in them. Just like that, organic compounds. Check the definition. Compounds which have carbon in them,
Have
okay?
is it oxygen?
No, 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 no. Compounds which have carbon in them are called organic
Carbon.
compounds, okay? Don't you have the note, what we wrote?
Okay.
Don't you have it?
Yeah, I have that down.
Yeah, so check it. We have
Yeah,
written
I
it.
have.
You can, okay. So organic compounds are compounds which contain carbon in them, and inorganic compounds, compounds which do not contain carbon are called inorganic compounds. But again, there are some exceptional cases like carbon dioxide, it is CO2. Carbon monoxide is CO. Okay, and carbonates, like it can be any carbonate like sodium carbonate, potassium carbonate, or anything. And then hydrogen carbonates are like bicarbonates. Okay, HCO3. So like carbonate is CO3, bicarbonate is HCO3. So it can be sodium bicarbonate, potassium bicarbonate, calcium carbonate, bicarbonate, any hydrogen carbonate. So these are, we don't group under organic compounds. Though they have carbon in them, we don't group these compounds under organic compounds. Okay. So what are the organic compounds in our syllabus? We'll be looking at all these. Like any carbon containing compound, right? So we will have these compounds. See, we'll be learning about alkanes in detail, alkenes, alcohols, carboxylic acids, esters. Okay, so all these are carbon containing compounds just as examples, and then we'll be learning about them. Just like now in inorganic chemistry, we learned group 1 elements, all the alkali metals and their reactions, how they reacted with water, with hydrogen, or whatever, with oxygen. And then when it comes to group 7, we had different types of reactions of halogens, right? We had displacement reactions, and then what else?
Yeah.
Reactions with hydrogen. When we dissolve it in water, it formed hydrogen. No, when we reacted with hydrogens, it formed hydrogen halides, right? Cl2 plus H2, HCl. Can remember? This was gas, and then when I dissolved this
Yeah.
in water, it was hydrochloric acid aqueous. So we looked at 4 types of reactions in group 7 and many types of reactions in group 1. Just like that, here organic compounds are compounds which contain carbon in them, but again some exceptional cases like carbon dioxide, carbon monoxide, carbonates, and hydrogen carbonates. And then examples of organic compounds: alkanes. So what are alkanes? Can you tell me what compounds do we group under alkanes?
They're so single bonds.
Yes, only single bonds. Okay,
Alkanes.
now yes, so when it comes to organic, you have
It's
learned this in school, right?
hydrocarbons.
You have learned it in school, no?
Yeah.
Okay, so organic
Yeah.
compounds, like we can just classify them. Okay, any carbon containing compounds like hydrocarbons, alkanes are single bonds. they should contain carbon-carbon single bond, okay? And then we have alkenes where
Yeah.
they should contain carbon-carbon double bonds. Now, if something has carbon oxygen bond, double bond between carbon and oxygen and a single bond between carbon and carbon, then this is still an alkane, okay? Like we can't take it as under alkenes. Understood? The double bond should
It's
be
still
present,
alkene.
means it we can't group it under alkene, okay? No, this is an ester. Yeah, it's
Okay.
an ester, okay? Here it's an ester. Ester is C double bond O and a R group here and R group here. Okay, but now this is another group. We can't group it under alkane. Alkanes means this should it must contain carbon carbon single bonds, and then here alkenes it should contain carbon carbon double bonds. Okay, and this is not an alkene here or an alkane too. Here we take it as esters. We'll come to that later. Okay, and then we have some other organic compounds like this. R group can be anything. Okay, I just write it as a variable group, or I can even write X here, anything. We normally write it as R. X means it goes as halogens now. Okay, so then we have alcohols. Alcohols are uh, organic compounds which contain OH group in it. Okay, so if something has an OH group attached to the
Yeah.
carbon, and then it can have anything else like CH2, CH3, or I'm just writing it, I'm not counting it. Carbon, how many bonds can carbon make?
Four.
4 bonds, okay? Yes. So if something contains a OH group in it, we can group it under alcohols. Now, is this an hydrocarbon?
No.
No, because it contains oxygen. Okay, hydrocarbons are compounds which contain only hydrogen and oxygen, but
Yeah.
this can be grouped as an organic compound because it contains carbon in it. Understood? And then this is an alcohol again because it contains the OH
Yeah.
group. Likewise, we have carboxylic acid. So carboxylic acids is something like this. We have C double bond O and a OH group in it. And here we can have anything. I'll just write it as R. Okay. Like with any R group. If I have this particular group in my compound, C double bond O and a OH group, then I call it as a carboxylic acid. All compounds like this. Okay. Clear? And then we
Miss,
have
what
S.
what is the R?
R means now, okay, I can write anything. We'll just take it like this. So I can even
Okay.
say C double bond OH, and then a carbon with 3 hydrogens, right? So it's like CH3, C double OH. This is also an carboxylic acid. Now, the C double bond OH, C, H here, another H, another carbon, H, and hydrogen here. So it's like CH3, CH2, C double OH. Do you see? This is also still a carboxylic acid, okay? This is the same, but this R group means here it can vary. Here the R group is CH3, here the R group is CH2, CH3. Understood? It's like the variable group. R group is like the
Yeah.
variable group. Okay? Clear?
Yeah.
Ah.
Okay.
Now it's the same for an alcohol too. Now if I take alcohols, I can write
Yeah.
CH3 and another COH, something like this, and then all other hydrogens. I can just fill it, or CH2, CH3, another R group with COH. Like the main factor here is carbon should be bonded with a hydroxide group, OH group here. Okay. So under organic compounds, we'll be learning about all these different groups. Single bond, carbon-carbon single bond containing
Yeah.
compounds as alkanes, carbon-carbon double bond containing compounds as alkenes, and then OH containing COH, okay, containing groups as alcohols, and carboxylic acids is C double OH. Esters is different. We'll see what that is, okay? Clear up to that? And then we looked
Yeah.
at different types of formulas. So empirical formula, molecular formula shows us the actual number of atoms present in a molecule. Empirical formula was the simplified form. And then we have the structural formula. So the structural formula, two types. What is it?
Structure formula is It shows like the atoms in the molecule and how they're
Ha-
joined together.
how they are joined, okay? The bonds will be shown. So structural formula shows how the atoms in a molecule are
Yeah,
joined. There's two types of structural formula. What is it?
there's displayed and
Yeah,
normal structure.
displayed, and what is the
Is
normal one? The condensed, okay? So displayed means we write it with the
condensed. Yeah.
bond like this here. Now this is displayed, okay? So this is the displayed form. Now if I should write the condensed form, I just write it without the bond. So it is CH3, CH2, CH2, CH3. Understood? So that was
Yeah.
the condensed form without the bonds. Normally, if they ask you to draw the structural formula, always draw it with the bonds. If they ask you only to, if the question mentions as condensed formula, then write it in the condensed form. Or else you should just go with the uh, structural displayed one. This is what we learned last class. Are you clear up to this? Can remember, na? We'll move to the next.
Yeah.
Okay, now
Yeah.
we
That's
should
good.
look at okay, just two new terms here. You should know what a homologous series is, and then you should know what is a functional group. Okay. Now, all the other types you know what an empirical formula is, the simple formula, molecular formula, all that, and then structural formula, the displayed one, and condensed, right? These were some new terms what we learned. And now just two new terms, functional group and homologous series. So functional group is an atom or a group of atoms that determines the chemical properties of a compound. They will not ask you for definition, but just know it, okay? So in alkanes, we don't say as the functional group is a single bond, but all alkanes have single bond, right? So because of that, all alkanes will have similar properties. Now, when we looked at group 1 and group 7 elements, like group 1 and group 7, they showed all the group 1 elements showed similar properties. Why was that?
Is it because of the electrons?
Yes, the electrons in the outer shell, right? Chemical properties depends on the number of electrons in the outer
Yeah.
shell. So because all group 1 elements have one electron in the outer shell, they can show similar chemical properties. And then when it comes to group 7, again the same. Group 8, we call them as noble gases. They do not react with anyone, all that because the chemical properties depend on number of electrons in the outer shell. All of them have 8 electrons. So they showed similar chemical properties. Okay, just like that, here we don't talk about the electrons here, but again, now all these groups, we saw different examples of organic compounds like alkanes, alkenes, carboxylic acids, and we have alcohols. I'll write like this. Okay. So all the carboxylic acids,
Yeah.
they are going to show similar chemical properties. All the alcohols, they are going to show similar chemical properties. All alkanes, same. All alkenes, same. That is because they have a common functional group. Now, for all carboxylic acids, the functional group is COOH group, right? All carboxylic acids has that. And then this OH, or all alcohols have this OH group. All alkenes have a double bond, carbon-carbon double bond. And all alkanes have a carbon-carbon single bond. Understood? So because that is common, because their functional group is common, they are going to show similar chemical properties. Clear?
Yeah.
Okay. And then again, homologous series is series, okay. Again, homologous series is a series of compounds with similar chemical properties because they have the same functional group. Again, it's the same. So I can say all alcohols, they have a homologous series here, alkenes have, and then alkanes have. Just know the definitions. And then we will have general formula for that. Now, are you clear with this functional group thing of all compounds, all different organic compounds?
Not, not really.
Okay. We'll just write it. Shall we write the different examples what we're going to
Yeah. I
look?
wrote the definition of homologous group.
Okay.
What's the definition of a functional group?
Functional group, wait, let me give you. So we'll first write this. Alkenes. So functional group is this. They will not ask for the definition. Okay. A functional group, atom or group of atoms that determine the chemical properties of a compound. Take it down if you want.
Okay, Amber.
Okay. So alkanes. Take it down as a table. Esters I'm not going to give you now. So alkanes, the functional group here. We'll write the functional group of all this. Or take it like this. So alkane, the functional group is carbon-carbon single bond, right? All alkanes are going to have this. If something has carbon-carbon single bond, we are going to group it under alkanes, understood? And then all alkenes are going
Yeah.
to have double bond, carbon-carbon double bond.
So
If
the
something
functional
has,
groups is like the name for them.
yes, okay, the group
Like
of atom, if
alkanes is
they
a
have
functional
that,
group. Alkenes. Yeah.
no. The group of atoms which is responsible for that particular thing. Now, if something has carbon-carbon double bond, then we group it under alkenes. So all alkenes have the functional group carbon-carbon double bond. Understood? And for alcohols, if they have OH group, then we group it under alcohol. So the functional group here is OH. And then here it's C double OH. If I draw it like this, I should draw it like this, C double bond O and OH.
Okay.
Now, are you clear with this? So if something has a carbon-carbon double bond, we group it under alkenes. Carbon-carbon single bond, it's an alkane. If it has an OH group, then alcohol. If something has C double bond or OH group, then it's a carboxylic acid. Okay. So a group of atoms which is responsible for similar chemical properties. Now all carboxylic acids will show similar chemical properties. All alcohols will show similar chemical properties. Now it's like this. I don't draw it. I'm just writing it. So think like this. This is also an alkane, right? And again, if I just draw this with 4 carbons, again, it's still an alkane. Do you get it? Because it has the same
Yeah.
functional group here. Here the functional group is the same. It has carbon-carbon single bond. And then when it comes to alkenes, still this is an alkene. And then even if I draw it with some 4 or 5 carbons, still an alkene. Another example of alkene. It is the same with alcohols and carboxylic acids also. So if I just take this as compound A and compound B, they are going to show similar chemical properties because they have the same functional group. Here that is the carbon-carbon double bond. Here A and B is going to show similar chemical properties because they have the same functional group, this carbon-carbon single bond. Okay?
Yeah.
Mm. So again, just a quick summary. Organic compounds with carbon containing compounds, and then examples, we have alkanes, alcohols, carboxylic acids, and we have something called esters. Okay? So and then you should know the functional group. Anything if it contains this, we just group under these categories. Okay? Clear up to that?
Yeah.
Okay, now we'll just stop with there. I'm not going to do homologous series or this general formula now. I'll just go to naming organic compounds. Now put the topic naming organic compounds.
Artemis.
Put the topic naming organic compounds.
Okay.
Okay, so here naming the organic compounds depends on the number of carbons present in a compound, and also we should know about the, what do I say? Okay, about the functional group and if there is any subchains. Okay, these are the 3 requirements you should know. First, don't write number of carbon atoms present. So if something has 1 carbon, it goes as meth. If something has
In
2
school, I
carbon,
learned
eth.
there was a saying monkey see. peanut butter.
Yeah, it's given here, monk. Okay. So it's met at prop and what is B?
Yeah,
Bute, no? Okay, bute is 4. And
yeah.
then pent is 5, H is, okay, hex is 6. Now, depending on the number of carbon atoms, we just write it like this, okay? Now, think like this C, 3 carbons, and this. Now, if I just don't draw anything, it's hydrogen, okay? I'm not going to, okay, for this I'll draw, or else just know that there is hydrogen here. Now, is this an alkane or an alkene or alcohol? Carboxylic acid, what is it? This
It's
compound.
alkene.
Alkene.
No, alkene. Alkene.
Alkane, good.
Alkene.
It's an alkane, right? And it's an alkane. So know that all the alkanes, the name ends with ANE. Okay? And all the
Yeah.
alkenes, it ends with ENE or EN. Yeah.
So there's methane and methane.
This is methane. No, no. Now here it's 3 carbon. So what is it?
It's propane.
Prop. Okay. So it goes as prop and then it's an alkane. So I end it with ane. So it's propane. Understood?
So methane would be, how would you do methane? Is there such a thing called methane?
No, no. Meth is ene is now double bond, right? So anyway, for sure it will have 2 carbons. So we don't have methane. Okay.
Um,
Understood?
yeah.
Okay. So that's how we name when it comes to alkanes and alkenes. And now when something has an OH group in it, we just go with OL. Okay. We just end a name with OL. Now we'll just take it like this CCOH. So all this is hydrogen. Then how many hydrogens? How many carbons? 2, right? So it goes as eth, and then it's an ane, ethan, or OL. Okay. 2. Okay, we'll just go with another carbon, hydroxide, OH group, and then H, all hydrogens here. So how many carbons here now?
There's 3,
3. So it's prop. Okay, and then alkane,
but it's
right? Like,
alcohol.
uh, yeah, it's an alcohol.
Isn't
But
that
how do it's an alcohol? You're correct because it has OH group, functional group. Okay, so now it should end with OL. Understood? So it goes as propanol.
okay.
It goes as butanol, pentanol, hexanol. It should end with OL. If something is an alcohol, it should end with
That's
OL.
why sanitize is called like ethanol.
Yes. Ethanol. Now, ethanol means it's an alcohol because it has OL in it. How many carbons?
1.
Eth,
Oh, two.
2, right? So CCOH, and then maybe we should draw it like this. Clear? Now, from the
Yeah.
data, I know eth is 2 carbons for sure. So I draw 2 carbons. And then ol means alcohol. So I put a hydro OH group here with attached to carbon. Okay? And then all others, now I know carbon can make 4 bonds. So just to make it, now carbon has already made 1 bond. So I just add 3 more hydrogens. And here carbon has made 2 bonds. So I add 2 more hydrogens. That's how you feel it. Understood?
Yeah.
Okay, when you do questions, we'll get it. This is just theory I'm going through. Okay, then sometimes we will have this chain branches. Okay, the side chains. Then we should know how to label that. Okay, so when they have branches or side chains in them, it goes like this. If it is a branch with only 1 carbon, then we say it methyl, ethyl. If it's 3, it goes on like that. Okay, propyl, butyl, likewise. Okay, now we'll go to an example. Are you clear with naming these compounds? Alkane and alkene. Okay, first, can you take this down? Coding the chain length and then just write all this. So this is for the carbon chain. Are you taking it down?
Yeah. Okay, Miss, I'm done.
Okay. So can you just try to draw two examples? So can you draw butane and propane? Right. So write examples.
Butane.
Butane. So ane means we know it's an alkane. You can mark it if you want. But means 4, right? So I should draw 4 carbons with single bonds only, and then fill the others with hydrogens, such that carbon has made 4 bonds. Understood?
Yeah.
Do the same for propane. So propane, ane means we know it's an alkane. Prop is 3. So 1, 2, 3, 3 carbons with all others hydrogens.
Okay, I'm done.
Okay, so next when it comes to alkenes, when there is a carbon-carbon double bond, we should okay, we should write, it should end it as ene. Okay, we should write the carbon number. Now here it's 4, so but, and then because it's an alkene, it ends with ene. Okay, now what is this 1 here, or what is these numbers here, 1 and 2? So we should also know, like we should also say where this double bond is present. Okay, so if I just go with C, okay, just put the topic, subtopic naming alkenes. First we'll write the rules, and then we will understand. Okay, so example, we'll just go like this. See, don't draw now. 4 carbons with a double bond here. So how many bonds will this make? Already see it has 1, 2, 3, so only one more, right? Understood?
Yeah.
Okay, 1, 2, 3, 4 here, this 4, and then again another hydrogen, here 3 hydrogens. Okay, so now this is but, meth, eth, Bute, 4 carbons, right? So it's bute and it is an alkene, so it should end with ene. Now we can't just write it as butene. I should mention in between what carbon atoms or like in which carbon this double bond is present. So when we are numbering carbon atoms, we should number such that the double bond or the functional group get the lowest number. Okay, now we'll just go like this. If I number it from this carbon 1, 2, 3, and 4, or if I number it in this direction, it goes as 1, 2, 3, and 4, right? So in any direction, the double bond is present in the second carbon atom. Understood? The lowest is 2, right? So I go as butene. So now butene means I know there's 4 carbon atoms. The double bond is present in the second carbon. Clear?
Yeah.
Okay. Now, if it's like this, see 2, 3, 4, and here. So now if I number this carbon atoms, now first I should number it, right? So I'm sure it's bute because 4 carbons, and then it's ene because it's an alkene. Now we should start numbering. If I number it in this direction, this is 1, 2, 3, and 4. So the double bond goes to the third carbon. If I number my compound in this direction, it's 1, 2, 3, and 4. So the double bond is in the first position. Do you get it? So should I write bute 1 ene or bute 3 ene?
Butene.
No, we go with the lowest number, okay? So you should write it as bute 1 ene. Understood? You should number it in a way the functional group gets the lowest number. If I number
So
it, yeah.
I'm not sure what you meant. It starts from 1, 2, 3, 4 on the top, and then 1, 2, 3,
No,
4 on
we
the
can
bottom.
number it in 2 ways, no dear. Like we should number it in a way that a functional group should get the lowest number, okay? So if I number it in this direction, see the functional group, the double bond containing carbon gets the third, 3, right? But if I number it in this
Yeah.
direction, the functional group
It'll
containing
become 1.
carbon gets 1. Do you get it? So you should get the lowest one. So numbering
Okay.
it in this is wrong. You
Yeah.
should go to number it like this. Okay. So it goes as bute 1 in.
Yeah.
Clear?
Clear.
Here it's just bute 2 in because even in both the directions, the double bond is in the second carbon. Okay.
Yeah.
Okay, take it in your own words, like however you can understand, and then just number it and write it as example 1. You can take this down. And then example 2, you can take this example, bute 1 in. And then I'll erase all this. You can just only number carbon in this way. Okay, so all this is hydrogen. Okay, you can say while numbering the carbon chain, the functional group,
Should be lowest. One
yes,
out of both ways.
yeah, should get the lowest number. Okay, so that's
Yeah.
the rule.
Yeah, I wrote it down.
Yeah, and then write down the examples with the name.
Yeah, I did.
Okay, send me
I
a pic.
did butene with the
Okay,
2
bute
and then
2
1.
in and bute 1 in. And then
Yeah.
always remember, see, when we are writing bute 1 in, I write bute, I put a hyphen, write 1, put a hyphen, and then in. So in between a letter and a number, we should always put a hyphen, okay? In between two numbers, comma is okay. But when there is a letter and alphabet, we just put a hyphen. That's the space. We just don't leave even a space. Like there is a way of writing it, the scientific way. Make sure you always write it with a hyphen in between, okay? Clear? Now see all this.
Yeah.
Just example, see pentane, just only alphabet, no hyphen or no commas. Here, when it comes to hyphen and then all the words. Okay. When it's two numbers, 2 comma 2 hyphen and then the letters. It goes like that. Okay, send me a pic. We'll just check it and move to the next.
There you go.
Okay, this is but 2 in, put a hyphen here, and then yeah, but 1 in. When you do questions, I think you'll be okay. Okay. No point in just giving notes in this. We'll try questions. Okay, now put the subtopic coding for branch chains. So when there is branches, or yeah, branches or like subchains there, then there's a way of labeling it. So naming it is like this. When there's a side chain with only one carbon, then it goes as methyl. When there's a side chain with 2 carbons, it goes as ethyl, propyl, butyl. It goes like that, okay? Now see this compound
Yeah.
here. We'll just go with this example. Okay, put the subtopic coding for branch chains. Okay, don't write it. Just put only the topic. We'll say this example. So C. So it's CH3, CH, CH2, CH3, and CH3 here. So is this an alkane or what? Alkane? What functional group is it?
It's a alkene. No, alkane. Alkane.
Alkane, no, or a single bond. So it's so for sure we know it should end with N here. And then if I'm numbering my now if I'm numbering the carbon chain, I should number it such that the branch is here, okay? Or yeah, the branch should get the lowest number. So I can number it like this: 1, 2, 3, and 4. Okay. If I number it in this direction, it will
What
be
about
1, 2,
the
3, and 4. No?
one branch of the CH3?
That we consider it
Onwards.
as a branch, okay? We don't take it as a long chain. Now, a long carbon chain means it should not break. Now, this is the chain that I can make, no? So these are the chains here. This one whole thing is a long chain, or I should consider this one, no? This, and then I should consider
Yeah.
this whole thing as a branch. Do you get it?
Yeah.
Sure, understood.
Yeah.
But now I don't go with the green because the green one will contain only 3 carbons. So when I choose the long chain, my long chain should have the highest number of carbons and my subchain should have only less. So if I go to the purple one, it has 4 carbons, no? So I go like this and then I consider this as the subchain. Clear?
So always pick the longest chain
Yeah,
as
always
the
we should
long
pick the
chain.
longest chain and then when we are numbering it, we should make sure that the functional group get the lowest number also. Okay,
Okay.
now we have okay, now we know that this is the long chain. Okay, but I can't number it like this 1, 2, 3, 4. That's wrong because now my function my branch is getting the highest number 3 here. But if I number it in this direction, my branch is getting 2 here. So I should go with numbering in this direction. Understood?
Yeah.
Ah,
Okay.
okay. So now it's an N and then 1, 2, 3, 4. But, right? So but, and then what is the subchain here? If it is only 1 carbon, it should be methyl, no? So it is methyl, 2 methyl butane. So methyl is in the 2, so it's 2 methyl butane. That's how you label it. So this is the functional group. This is the number of carbons in the long chain. And then before that, if there is any subchains, sub branches, then we should do it. Branches, then we should add that in front. Clear? So it's 2-methyl butane.
Yeah.
Okay, take it down.
Miss, does that say methane? Methylene?
Methylene, no, it goes as 2-methyl. That is the branch here. And then this is the long chain, butane. You write it like 2-methyl butane.
Why is
So
it methyl?
because here the branch is CH3, no? CH3 means methyl. Now here, if it is CH2, CH3, then ethyl. It goes like that. The branches. Now there is a way for coding branches also. So if the branch has CH3, it's methyl. It ends with YL, okay? It's 2. If it's a branch with 2 carbon, then ethyl. If it's a branch with 3 carbons, propyl. Okay?
Okay.
Okay, this is the branch and this is the long chain, bute. Because our long chain contains 4 carbons and because it's an alkane, it's butane.
This comes up in IGs.
Yes, yes. We have done past paper questions in organic now, can't you remember?
But I never heard of 2-methyl butane.
No, it comes, okay? Like, we'll see. When we are doing questions, I think you'll be okay. Now, you can't skip this also because you have already skipped, I think, inorganic. It was difficult, no? Past papers for you. And this is just the last, your 4th chapter, and we have only physical. Anyway, you have to somehow understand it.
Miss, I still don't understand the methyl. Is it because it's CH3, the branch?
Yes,
Oh,
yes, yes, yes. It's because of the branch. Now you know why we put bute, right? That's because it has the long chain
yeah,
has 4
because there's
carbon.
4 long chain has 4.
Just like that, methyl is because the branch is CH3.
The
If the
small
branch
chain.
is if the branch is CH2, CH3 with 2 carbons, 2 carbons means eth. Because it's a branch, I put YL, ethyl.
Okay.
Ah,
Yeah.
if it's CH2, CH2, CH3, then 3 carbons means prop. But if it is if it comes as a branch, then I'll propyl. Okay, now here it's a 1 carbon, right? So it's meth. But now because it's branch, I'll methyl. Okay, clear? You're muted.
Miss, for the propyl, is it
Propyl is
CH2, CH2, CH3?
Yes, prop is 3 carbons, no? And then if this comes as a branch, then we write it as propyl. Okay, I'll just take it. I'll just write this.
Is that CH2 in the middle for
Yeah.
propyl?
Yes.
I can't really see it.
Okay, now see if I have something like this, CH3, CH2, CH. Something like this, okay? But here if I get a compound like this, we will not label it. Now my long chain will be this, no? This whole thing. Do you get it? Be like 1, 2, 3, 4,
Yeah.
5, 6. That's the long chain. Now if I choose this as my long chain, it will have only
So
4 carbons.
this will be methyl uh methyl 6.
Yes, it will be 4 methyl
Why is it 4?
because the branch is on the 4th carbon, no? So we should mention that.
Oh,
Okay.
the
Now
branch is
see
on the
here.
4th carbon.
Yeah.
Where's the 4th carbon?
See, now if this is the whole compound, I should label, I should number my long chain like this, no? 1, 2, 3, 4, 5, and 6. Got it?
Oh, okay, yeah. Yeah.
And then this will be the branch. Now I can't consider this as the long chain because then it will
So
have
it will
only
be
4
hexane.
carbons. Yeah, 4 methyl hexane. Clear?
Hexane.
Yeah. Understood?
Yeah, I'll write this down.
Okay.
This isn't it propyl for propyl?
Yes, propyl, for propyl it will be propyl, but here this compound, the branch, we don't consider it as propyl, no? Because this is the long chain now. So this is the branch. Now I can't consider
Oh,
this
okay, yeah.
whole thing as the long chain and this as the branch because then it will have on my long chain will have 4 carbons only, no? But now I have another way to get a, we should always choose the longer carbon chain, right? Okay.
Yeah. Okay. And then
Okay, give me a minute. Now when there is now this is just example 1 and example 2. We'll go with another example. So when there is 2 uh branches in 1 carbon, okay, if it's like this, see this atom, this compound here, okay, CH3. Now I should first find my long chain. So I can write it like 1, 2, 3 in
yes,
this way.
your screen is
See, is it okay now?
not so clear.
Okay. Now if this is the compound, okay. So first I should number my long chain. That's the first rule now. So I can number it like this, how they have numbered 1, 2, 3. Then these two will be my branch. Understood? Or if I number it like 1, 2, and 3, again, it will be like this and this will be my branches. Okay, clear?
And then what do you do with the 2 branches?
Now, okay, if are you clear with how we have labeled the long chain?
Yeah.
Okay, that's done. Now
Yeah.
first, I know, so my long chain is 3 carbon, so it's prop. and then it will be an alkane. So it's propane. Okay. Now so that's the long chain is done. The functional group is done. I should name my branches. So here it's, what is my branch?
It's two.
No, no, no. Okay, it's in my
It's on the
second
second.
carbon. Second carbon, okay. What is my name of the branch?
Yeah.
CH3.
It's ethyl.
It, CH3, no dear.
No, methyl.
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 Methyl. Now I have two methyl groups, no, in the second carbon. So it goes as dimethyl.
Yeah.
2 comma 2
Di.
dimethyl
Okay.
propane. Okay. 2 comma 2 means both the methyl is present in the like is to the second carbon. Okay. Clear? So
Yeah.
take this down and then write
Yeah.
this.
Okay. And then
Okay, now can you write this 2 comma 3 dimethyl but 2 in and try to draw the structure for this.
two.
Now you should know whatever comes like but, this is the carbon chain, this is the functional group, and this is all about the branches. Understood?
Yeah.
Try to draw it.
What's the two comma mean?
2 comma 3 means now it's dimethyl. So one methyl should be in the second carbon, the other methyl should be in the third carbon. Here if it's 2 comma 2 dimethyl, one methyl was in the second, the other one also was in the second carbon. Understood?
Okay. Yeah. Four carbons. Mm, CH3. There's going to be three CH3s.
Yeah, can you send me a pic once you're done?
Miss, I'm not sure where to put the third CH3. If it's on the second, CH, I mean C.
Yeah, methyl means it is meth is 1, no? So CH3. So there should be dimethyl. So 2
Oh, it's two
CH3 in the,
CH3.
but 2
Okay,
CH3,
two
one in the
CH3.
second carbon, the other one in the third carbon. Okay, it's like this. Wait. So
Yeah,
2 comma 3 dimethyl butene. Now my long chain should contain 4 carbons.
yeah.
1, 2, 3, 4. And then uh so if I just number it as 1, 2, 3, and 4, my double bond should be present in the second carbon. So I put it here. Okay.
Yeah.
Now we'll
Okay,
draw the
Miss, I'll send
subchains.
it to
So
you.
the subchains will be 2 and 3, right? So in the second one, CH3, and in the third one, a CH3. If I want, I can just draw it down, and then I fill all others. Clear? Yeah, send it.
Wait, why is one of the H3s on different branch?
Okay. So because the name said 2 comma 3, so the first one should be in the second carbon, the other one should be in the third carbon. Here, if it's 2 comma 2, means both the
Ah,
methyl
okay.
is in the second carbon, attached to the second carbon. Okay.
2, 2, right?
Yeah.
Okay. Yeah. So could it be more than three numbers?
Yes. 2 comma 3
Or
comma
comma
4. Yeah, no
4?
problem. Yes. Okay. Done. Did you send it?
Uh,
Take
yeah,
down your own
yeah,
note.
I'll send
Like,
it now.
yeah, take it down, whatever the rules you can.
Yeah, I'm going to make a note.
2 comma 3 dimethyl butene. Yeah. Okay. Yeah. Shall we move on to some questions and try it?
Yep.
Okay. Can you try 2 methyl butane? And then 2 comma 2 dimethyl propane. So here you can just cut it like this. Should be the branch. This is the long chain, and this is my functional group. Okay. So first I'll draw the long chain. But 1, 2, 3, 4. Okay.
Yeah, Miss, I'll send you my note for it, like the how I distinguish the.
Okay. Send it also.
Yeah, I sent it.
Second carbon, third carbon. That's the second methyl carbon. 2 methyl carbons. What's the last one you have written? For ene, double bond, no? Okay.
Yeah.
And then if you want, you can also take it down. Like you can just cut it from this, right? So
Yeah.
this is the long chain with functional group, right? and this is the, whatever comes in front is the branch. Okay, after YL, all others is the long chain.
Yeah.
Okay, now shall we move on to
Okay.
this question? So first one, we'll just go with
Yeah.
methyl butane. Did we try this methyl butane?
No.
Okay, so here this is L, right? So this is the long chain. So it contains methyl propbute, 4 carbons with N, so just double bonds there, and then 2 methyl. I'll just number it 1, 2, 3, 4. So my methyl group is in the second one. So I just put a CH3 here, and then fill all others.
Yeah.
Clear?
Yeah.
Do
Yeah.
the same for 2,2-dimethyl propane.
I'm done.
Yeah, did you do 2,2-dimethyl propane? Send your answer.
Yeah.
So it's this, right? So prop is met at prop. If I just number it, and then N is alkane, that is done. So 2,2-dimethyl. I will have methyl in both here, right? Understood? Correct. And then fill all others.
Yeah.
Did you do it like that?
Yeah. I sent it.
Now, okay. Now here, yes, correct. Okay.
Miss, what's the hardest it can get? A question like this?
No, you will be just getting only these level questions. Okay. Like you can get it with a branch chain or without a branch chain. So if it's with the branch chain, the branches will be on the same carbon. Then it goes like this. If it's on the branches are on the different carbon, then you should know to number it clearly and do it. Okay, those are the only question types you can get. Yeah, can you do these questions? Draw the structure and displayed formula. Just draw the displayed formula for all this. Question B. Try it.
Question, which one?
Question B. Ethane, propan 1 all, bute 2-ene, all that. Vanda.
Miss, we didn't do propanol, like any of the alls.
Okay, but all means it
Methanol.
ends with alcohol, no? OH group.
So H.
Yeah, so it should be an OH,
So
but in
it's
the
in the
first
first
one, because it
carbon,
says one OL, and
first
prop
carbon.
means 3 carbons. It's
Shall I send you my answers, Ruth?
yeah, send it, we'll check.
One second, I'll send you a few pictures.
Yeah, send it.
There.
Okay. So ethane, eth, right? Eth is 2 carbons and it's an alkane. Okay. Propan 1 ol. So prop is 3 carbons. 1 ol means 1 in the first carbon. It should be the OH. Or you can even draw it here. Okay. Then the numbering
Yeah.
will go like this: 1, 2, and 3. This is correct. And then we have butene. But 2. Yeah. So it goes as 1, 2. Okay. And then hexane, that's easy. Methanol, meth is 1, ol is OH, and then 2 methyl propane. Prop is 3, 2 methyl. Okay, in the second one. Methyl propene. Okay, now if there is no 1 or 2 here in front of ene, it means the double bond is present in the first carbon, okay? Do you get it?
Yeah.
If it has
Yeah.
been here, then it would have been methyl prop 2 ene. Okay?
Yeah.
Oh,
Yeah.
that's okay. And then pent 1 ene. Yeah, they have just given it as 1. Okay, correct. I think your carbon is correct, no? Don't make sure the carbon bonds only makes only 4 bonds, okay? Check that.
Yeah.
I did not check that in your answers. Okay, can you just write down the names of the following hydrocarbons for this? Do it.
It's first one is it's meth something. Methane? No.
Methane, no?
Methane. Propene.
Is it in? Check it.
Propane.
Propane, no? No double bonds here. And this should also be an alkane. If it's an alkene, see, double bond is given if it's an alkene. So all whatever there is
Okay.
no double bonds, then just go with an ane.
So then that's hexane.
Yes.
The four is propene.
Prop.
Second one is
Yeah, you can write it as prop ene or prop 1 ene. Anything is correct. Propene or prop
this
1 ene.
is ethene.
Yeah, ethane. Yeah,
Ethene.
ETHNE. Wait. And then I can
And
also
then
say 1 ene.
this is but 1 ene.
Yeah, but 1 ene. No? So make sure you write the hyphens. But 1 ene. And then the other one?
Next one is butane.
No,
No,
no.
no, butanol. Butanol.
Prop, right?
No,
3
propanol.
carbons.
Propanol. Yeah,
Propanol. Yeah, propanol or propan 1 nol. Now, if it's propan 1 nol, you should go mark it like this, okay? 1, 2, 3. That's how you number the carbon chain. Now, we can't number it like this. Then our functional group will get the biggest number. It should get the smallest number, right? So this is how we should number the long chain, okay?
yeah.
Okay, now think like this. I
And
have
then
CH3,
butanol.
CH, CH3, CH2, OH. Can you name this compound?
That's
So first we should mark the long chain.
two dimethyl
Is it dimethyl or methyl?
uh oh
No,
no, it's
long
methyl.
chain.
Yeah.
Now this
Two
should be my
methyl,
long chain, okay? So 1,
yeah,
2, and 3. So
propanol.
2
Two
methyl
methyl propanol.
propanol. Yeah, okay, propanol. Understood? So you can't take, okay, you can also take this as the long chain. Then 1, 2, 3. Again, then it's going to be 2 methyl
Is that
propane.
correct? Two methyl propanol.
Yeah, that's correct. Okay. Or I can also number my chain like this: 1, 2, and 3.
Yeah,
Even okay, clear, right? Naming compounds and drawing the structural
yeah,
formulas and everything.
yeah.
Now we have something called structural isomers. I'm not going to do it now.
Wait,
We'll
miss, could you go back for a second?
Yeah, which one, dear?
For the eighth one.
Ah,
Isn't
okay,
that
we'll see.
methyl also?
No, this is a carboxylic acid, no? So it should be CH3, CH2, CH. This is an O. So it should be C
So it's
double bond
alcohol.
O, H. Is it an alcohol? Wait to draw it and see.
First carbon has 3 hydrogens.
1, 2, 3, 4. Okay. So this 3 here, this 2. And then 1 hydrogen here. It should be a double bond O, no?
But then it doesn't show double bond
Yeah, it
on
won't
the
show
question.
double bond. No, it should be, wait, let me check. See if I have drawn everything. I think I'm missing 1 hydrogen there. Have they given 1 hydrogen extra? Or what?
CH3, CH3, CH. Oh, yeah, there's one extra OH.
1 extra, no?
Yeah, so it's alcohol. It's OH on one branch and then H separately on another branch.
Is it butane 2-ol then? Yeah.
Butane. Isn't it butane 1-ol? It's on
1,
the first carbon.
2, 3, and 4. Okay.
So it's on the first carbon.
No, butane 2-ol. It can't be on the first carbon. See, if you're, I can't number it like this. I should number this such that this gets the smallest one. No? So 1, 2, 3, 4. It should be on the second carbon. Okay.
Okay.
COH, CH3, H, and then CH2, CH3. Okay. Clear?
It's on the, oh yeah, it's branching out on the second carbon. Okay.
Yeah. So it's
Yeah.
butane 2-ol. If you want, just draw this and take it down if you want. Okay. Or else no problem. I think you're okay with naming the compounds and drawing it now.
Yeah.
Okay. So take your own note, or like if you see a name, you should know. The first part shows us the branch, the other one shows us the long chain with the functional group. If you know that, you can draw it or label it. Okay. And then structural isomerism, we'll come to that later. Now I'm not doing it. With the naming thing, if I do, I think you'll get confused again. That's a little, we should practice more questions there. And then we have some, okay, a quick introductory at alcohols. We'll just go through. So alcohols are compounds with OH functional group, no? And the name ends with OL. I just said you that. We'll come to that later as a separate section. So I'm just
Yeah.
telling you. Now see, this is methanol, 1 carbon with a OH group. So meth, ol. 2 carbons with OH group, ethanol. Propan, 1
Miss,
ol. Propan.
for these, could you just put OH in one branch rather than doing separately O and then H?
Just like this.
Like
Yeah, you can do that,
without
but
this.
better to go with this, okay? Because this is how the textbook goes, no? Even this is correct.
Okay.
Okay. Yeah, but better
Yeah.
to go with this because when we look at reactions, you will understand. It's easy so that we can just remove the hydrogen like this. It goes away. Okay. So for always remember
Yeah.
with alcohols, just go with this then separately. Now naming all that is okay, no? With propan 1-ol, 2-ol, or whatever like that. Okay. And then we have chemical reactions of organic compounds. So we'll just go through this. I'm not going to give you note now. See, we have some chemical reactions like this. Now, when it comes to inorganic compounds, we looked at chemical reactions. With water, they can react to form what? Acids or like alkali solutions and all that. With hydrogen, it forms something. With other metals, it forms displacement reactions. So the same thing here, okay? but we give different names for these compounds and different compounds. Okay, so combustion. See, propane can undergo combustion is of two types: complete combustion and incomplete. If there is adequate amount of oxygen, then complete combustion. What are the products of complete combustion?
Complete combustion is carbon dioxide,
Carbon
water.
dioxide and water. Okay, if it's incomplete combustion, then it's carbon monoxide and water. Okay, it's not given here. It's carbon monoxide and water. So some organic compounds can undergo combustion reaction. So see, it can be anything: C3H8, C4H8, or like C2H5OH, and it can be anything. Okay, CH2, CH3, CH3, or something like that. CH2, CH3. If they give us this compound X and tell us to write the combustion reaction, then you just should put less oxygen. The products will be the same: carbon dioxide and water. Okay, and then you should know to balance the equations. Next, see the physical state. Mostly the physical state of organic compounds will be given. Oxygen is gas, water in liquid state, and then carbon dioxide in gas. Okay.
Yeah.
That is done. And then we have something called substitution reaction. So we'll come to that later. And then we have something called addition reaction, where the double bond breaks and something adds. And substitution is one hydrogen gets substituted by another element. Okay, we'll just go through this. So see, so substitution, see, I have CH3. When I react it with bromine, see, one bromine just comes and gets the place of hydrogen here. So now I have this compound. And then in this place, in the bromine's place, now I have hydrogen. It's substitution reaction, right? One atom is replaced by another atom. Okay, there are some group of compounds now out of alkanes, alkenes, alcohols, carboxylic acids, and esters. What we will be learning after this in detail. Some of these compounds undergo combustion, some undergo substitution reactions, some undergo addition reactions. That's what we are going to learn in detail. Okay, clear? Next we have addition. So addition means double bond containing compounds, either bond breaks and then bromine and bromine is added. Got an idea?
Okay.
We'll be learning this in detail, so I'm not doing this now in this chapter. So
you
this
can only
chapter
do addition reactions with alkenes, right?
Alkenes, yes. Okay.
Okay.
Not with any alkanes. Now we can't now because already the carbon has made 4 bonds. Can we go and add something inside here? No, we can only replace something. So that's substitution. We can't add it. Because carbon C, it already have made 4 bonds. So we can't go and add something and tell it to make a 5th bond. Okay. So no addition. Only alkenes will undergo addition reaction. That's just they have introduced it here. No need to do it now. Clear after this?
Yeah.
Okay. So again, just in short, you should know what organic compounds are, different types, and then what functional groups each type has, naming the organic compounds. Only that in this chapter. Clear?
Yeah.
Okay. Now we'll move on to the next one. I'm skipping crude oil. I'll come to that later. And we'll go to alkanes now. So put the topic. Alkanes in detail. So what are alkanes? Carbon-carbon single bond containing compounds. Okay?
Yeah.
Okay. So alkanes are the simplest family of hydrocarbons. They just contain only carbon and hydrogen only. Those are called hydrocarbons. Okay. So the simplest form of hydrocarbons is alkanes. Okay. They are mostly used as fuels. And then these are some alkanes. Now we'll just go through this. See, CH4. That's the simplest one, right? With 1 carbon, meth. And then if it's with 2 carbon, ethane. If it's with 3 carbon, propane. 4 carbons, butane. 5 carbon, pentane, hexane. Likewise, it can go on. And then if they ask
What's
us
after hexene?
after hex, it's hept. No? Hept is 7. It goes as heptane. Oct is 8. No? Octane, nano, nonane. It should be with 9 is nano, I think. Okay. And then 10 is deca. Yeah. Okay. So we have this. Now, if they ask you to write the name You know the names. The molecular formula is the actual number of atoms. You can just count this and write it here. Structural formula, see, they have written the condensed formula. This is the displayed structural formula. Clear? Go through this table.
Yeah, it's clear.
Okay, now see, alkanes, they have the same functional group, right? What is their functional group? What is the functional group of alkanes?
It's a single bond.
What single
Carbon.
bond?
Between
Carbon,
carbon.
carbon, single bond, okay? Now, even in between carbon and hydrogen, it's a single bond. So that doesn't make it an alkane. The carbon, double single bond should be in between carbon and carbon, okay? Okay, they have the same functional group. So I said if something have the same functional group, it is going to have similar chemical properties. So all these alkanes are going to show similar chemical properties. That means if methane reacts with oxygen to produce carbon dioxide and water, this is also going to react with oxygen to produce the same. All will undergo combustion reaction. If something, if one alkane undergoes substitution reaction, all these also can undergo substitution reaction. Understood? If one can't undergo
Yeah.
addition, all these also cannot undergo addition reactions because they have same functional groups. So they are going to have same chemical properties. Are you clear with this point? And then they show a trend in physical properties. We will see that the physical properties show a trend and then can be described as same general formula. They have a same general formula and different from the next by a CH2 unit. I'll show you that. Now see the difference between methane and ethane. Is one CH2 group, right? See, this plus a CH2 group will give us the second one, will give us this. Understood?
Yeah.
And then this whole thing plus another CH2 group will give us propane. This whole thing with another CH2 group will give us butane. Like the difference between one and the other one is just a CH2 group. Understand the points? Clear?
Yeah.
Okay. Now we'll see. I said the physical properties increases as a trend. So maybe downwards the group, I can say the boiling point increases. Why? These are covalent compounds. So when the molecular mass increases. No, now here the molecular mass is 12 plus 1 into 4. Right? Here it's 12 plus 1 into 3 plus 12 plus 1 into 3. Okay. Can understand?
Yeah.
So downwards the group, when the molecular mass increases, the intermolecular forces increase, the strength of the intermolecular force increase, so the energy required to break the intermolecular forces increase, so the boiling point increases. See, it is as a gradual trend. No? So likewise, melting boiling points can increase in a proper way and then differ from the next by a CH2 unit. Now we'll see what is the general formula for any alkane. So this is the general formula for any alkanes. Okay, CnH2n plus 2. If the N is the number of carbon atoms, we'll take it like this. So for alkanes, it's CnH2n plus 2. Now, if N is 5, then it goes as C5H2 into 5 plus 2. So it's C5H12. Okay, so it's this. So there is a general formula for alkanes. We can calculate the number of carbons and atoms present. Now, your questions can say if N equals 100 or 10 or what, okay, 10 or like 17 or something, then also we can just use the same thing. So then carbon 17, H2 into 17 plus 2, because now we can't be always drawing the 17 carbon atoms and then drawing all the hydrogen atoms and counting, right? So this is the short way. Are you clear why we have a general formula?
Yeah.
Okay, sure, right?
Yeah.
Understood that? Okay, so that's the general formula. And then see, uh, the consecutive one increases differs from just a CH2 unit. From CH4 methane to ethane, it differs by just a CH2. Ethane to propane differs by a CH2. Propane to butane, it should differ by a CH2, okay? Okay, now you asked me what is a homologous series. So homologous series means a series of compounds which have all these properties. So alkanes act as a series. All the alkenes, they act as a homologous series. All the alcohols, they act as homologous series likewise, okay? So if something contains the same or shows all these properties, then we can say that it acts as a homologous series. Okay, now give me it's the page number 287. Okay. Homologous series is a series of compounds with similar chemical properties because they have similar functional group. If any compound has the same functional group, just we can call them as the homologous series. They will not ask you for the definition, just know that, okay? So all the alkanes is a series. All alkenes is just another set of series. Now all homologous series have these properties. All alkanes will show these properties. All alkenes will show. All carboxylic acids will show these properties. Clear? They will have their own functional group. They will have their similar chemical properties. They will show a trend. They will have a general formula, and they can okay, this is for alkanes, right? Differ by CH2 unit. Likewise, they will have another unit. Likewise. Got an idea? Is it too much today?
Yeah. It's okay, I guess. I understood most of it, or all of it.
Okay. Okay, so under alkanes, write this point. And then you can, if you want, you can take this down. Examples of some alkanes. Put the topic like that, and then you can write 2 or 3 of this, and then with the name. Do it.
Must have to draw the displayed formula.
Yeah, just draw the displayed formula of one or like just first three compounds, and you can write the name.
Okay, I'm done.
Okay, do you know saturated compounds and unsaturated compounds?
The saturated ones are the alkanes and the unsaturated are alkenes.
Yes. So saturated are ones which contain carbon single bonds. Okay, take it down. Saturated compounds. Do you want to?
Yeah, I'll take it down.
Yeah, compounds containing. Again, you should mention it as carbon single bonds. Unsaturated compounds containing carbon double or triple bonds. Do you know that carbon can make triple bonds also? Okay. Now, we just learned only about alkanes and alkenes. No, alkanes is this example here. Here, unsaturated compounds, we have alkenes and we have something called alkynes. Alkynes are compounds with carbon-carbon triple bond. Okay, C double bond C. This is an example of an alkene. Okay, so carbon can make maximum 4 bonds. So it's a compound like this. See, 3 bonds in between carbon and then hydrogen. Okay, so this is an alkyne. You'll learn it in your A levels, not now. This is alkene. So both of these are unsaturated compounds. Here it's saturated, means single bonds.
Yeah.
Take it down. Okay, are you done?
Compounds containing C double bonds. Okay, watch it. Okay, I'm done.
Okay. So next star point. Take it as a note. See if you understood all these points here.
This is only for alkenes?
Yeah, this is only for alkanes. Sorry, not alkenes. Alkanes, yes. No, even when it comes to alkenes, it's going to be the same. They will have same functional group, so same chemical properties, same physical properties. We'll have a general formula, okay? So I'm just giving, we are studying only about alkanes here, so I'm just giving only about alkanes. I'll be giving the same note for alkenes also. Understood? So all organic compounds, it's the same thing. And then we'll write the general formula of so you can write CnH2n plus 2, and if you want you can box it, okay? And then we'll do 2 examples. If n equals 5, you can substitute it and do it, and then do it for if n equals 17. Understood? Here the n is the carbon number. N is the carbon number. Memorize the general formulas. Just like we learned about elements, about the properties of sodium, about the properties of all noble gases, and likewise, here now we are learning about a group of other compounds, carbon containing compounds, okay? Simple, it's something like that.
And then for the alkenes, it's CnH2n.
Alkenes, yes.
Okay, I'm done.
Okay, so what should be the answer here? Send your note. So here it should be C5H2 into 5 plus 2. C5H12. And here's
C5H12.
C17H2 into 17 plus 2. What's the answer?
That's
36.
36. Yeah.
Okay. Send me a note, we'll just check it. Okay. So next subtopic. So they show a trend, right? The first 4 alkanes are gases at room temperature, and then all others liquids. And then from C18 onwards, it's solids, okay? They appear to be as solids. It's like this. CH4, and then I had C2H, and then C3, C4, C5, like, okay? So C1 to C5, it's mostly gases, and then liquids, C18 onwards, when there is an alkane, it will be in solid state. Okay, clear?
Yeah.
So methane, ethane, propane, butane, they are gases, okay, at room temperature. Alkanes are gases. All others liquids and solids start from C18. So see, there's a trend downwards when the carbon number increases, the physical state differs.
Yeah.
Write the numbers properly here, C18H38, I have just typed it. So why does boiling point increases downwards or when the carbon number increase? That is because when the number of carbon atoms increase, this intermolecular force increase, so more energy has to be provided, and then therefore boiling point increases. Okay, the same thing what we learned under covalent compounds.
Okay.
Okay, make it fast.
Okay.
Okay, next subtopic, chemical properties of alkanes. Okay, because Navara, would you? Okay, alkanes are fairly unreactive compounds. That's because now they have only carbon, carbon, and carbon hydrogen containing bonds, right? Okay, so it's hard to break it and they don't react. And these bonds are strong, covalent bonds. So it's hard to break. Due to all those reasons, we can just consider alkanes as unreactive and then see they are saturated. This carbon has already made 4 bonds, so it will not even think of like reacting or like breaking the bond or making any new bonds. Okay, so when there is a double bond, when we compare an alkane and an alkene, this is more reactive. He's still not saturated, right? So he will tend to break this double bond and become single bonds. Now he's already having single bonds, so he's like stable. Okay, clear. Alkanes are unreactive
Yeah.
compounds because they have strong carbon carbon and carbon hydrogen single bonds, because they have strong.
This is everything made out of hydrogen, like all the elements.
What elements? What
Like
compounds?
everything. Like everything is like made out of hydrogen bonds, right? Like every element, like uranium, lithium. Is that true?
How can you say lithium is made up of hydrogen? Lithium is lithium atoms.
No, like in biology, they told the class that um, every the like I think it was in DNA there was hydrogen bonds.
Ah, yes, yes. DNA has hydrogen, okay? Now it's like this
So
in
does
bio.
that also apply to chemistry as well?
Okay. Now, if you say lithium contains hydrogen, no, lithium has only lithium atoms. It's like this. Just think a gold ring. Now, this is a gold metal, right? Okay.
Yeah,
So this will have only gold atoms in it. You know what is an atom? Proton, neutron, electron, just arranged in a way like
yeah,
that. We have that ring. Lithium again, same, it will be same like that. Uranium, it will be same. Magnesium, just only magnesium atoms. Okay. When two or more of these combine together, then we will have all the other compounds. Now DNA is made up of carbon, hydrogen, and oxygen combined in different ways. Okay.
um,
When it comes,
yeah,
so then it has more, yeah, most of biologically, most of the compounds, not only biological compounds, most of the compounds are made up of hydrogen. That we can say it like that, but not metals, not elements. Elements are just containing only one type of atom now. Okay, use the terms clearly. Compounds, yes, most of the compounds they have hydrogen in it. Like even carbohydrates, proteins, lipids, in even in our cell membrane will have carbon and hydrogen in it. Okay. And then what else? Our nails, hair, that is a type of protein, no? So proteins, they contain carbon, hydrogen, oxygen, and nitrogen. That doesn't mean individual atoms, they will be bonded in some other way, okay? So DNA, there is like hydrogen bonds in between, no? And then we have all other bases. Yeah.
yeah.
Wait. Okay. Now, though we just see DNA as this structure here, okay, if we see it in detail, it is made up of these bases. Here, this is how one base will look like. So this one base can have, like, see, 6 hydrogens and then oxygen, nitrogen, hydrogen, oxygen, and all that. Understood? So all that composition in this, now this is a compound. This whole thing as one thing is DNA. The same thing applies for everything. Our cell membrane, our carbohydrates, whatever we eat, or any protein, lipids, all the compounds. Okay? Yeah.
Yeah.
So all the compounds, they contain mostly hydrogen and carbon in them.
Okay. Yeah.
Mostly it's carbon. That is why we study it as a whole different section in chemistry.
Yeah. Okay, I wrote down everything.
Okay, next put the topic reactions of alkanes. So alkanes show 2 reactions. First, right, combustion. And then we have something called substitution reaction. Okay, substitution reaction. These are the two reactions we are going to study under alkanes. Just like in halogens, we had displacement and then some other halogen reacting with hydrogen, halogen dissolving in water or something, all that. So here under alkanes, only these two. If you know this is enough. So combustion is easy, right? We have two types, complete combustion and incomplete combustion. Complete combustion produces carbon dioxide and water. It can be any alkane. And then incomplete, it can be any alkane again. It will produce carbon monoxide and water or carbon and water. Okay?
Yeah.
Okay, just first take this down.
Yeah, I wrote it down.
Okay, and then put the subtopic combustion reaction or combustion.
Okay.
Okay, and then again you can say two types. Complete combustion, and then we have incomplete combustion. Okay, so we'll stop with that and we'll do the reactions later. Okay, so that's it. We'll be done. Once we're done with reactions, we'll be done with alkanes. We can move into alkenes. Okay. Understood up to this? Like, do okay?
Yeah.
Are you okay with it? Okay, so go through all the units and come, like all the notes, whatever we wrote today. Next class is tomorrow, 6:30 Sri Lankan time.
Tuesday, right? Tuesday, right?
No, dear, tomorrow. Like I have a painting to do, no?
Oh yeah, Sunday.
Yeah, so tomorrow at 6:30 then. Inshallah.
6:30. Yeah.
Yeah, okay, dear. Then bye.
Okay. Bye, miss.